Hi, everybody. Professor Monty here, and today let's look at rules for integration. So remember, with integration, we're finding antiderivatives. So for instance, this is the integral sign. This goes with the dx. So we're finding the antiderivative of k, but we want the family of all antiderivatives of that, or all functions whose derivative is just k. All right, so here's our first one. K is a constant, and I know that because I say dx, so that means x is the variable. Well, I need something whose antiderivative is k. Well, that's just going to be k times x plus some constant, because some constant, when you take the derivative, is going to go to 0, so it's not going to matter. So for instance, an example of that would be if I've got the integral, let's say 7 with respect to x. I just get 7x plus c. And we can check that by taking the derivative. Oh, the derivative of 7x is 7 plus c would be plus 0, so it doesn't add anything. So, oh, I just get 7. Now, this c may be a 0, so it's just 7x, but it may be a 5, 7x plus 5. Oh, the derivative of 7x plus 5 is still just 7, or 7x minus 13. It doesn't matter what the constant is, it's still going to go away when we take the derivative. The second one's the power rule. Now, this is the big one that you're going to use over and over, the most frequent one you use. And it says, okay, if I've got x to the n with respect to x and I want to integrate it, I'm going to go up 1 in the exponent instead of down 1 like I do with derivatives. Remember, we're going backwards. And then whatever I go up to, I have to multiply by that reciprocal. And then again, put the plus c. Let me show you how it works. Say I've got the integral of x to the 9th power with respect to x. I go up 1 in the exponent, so it's going to be x to the 10th, but I have to multiply by the reciprocal. So it's 1/10 x to the 10th, again, plus c. And remember, to check this, we just take the derivative. Well, if I'm taking the derivative of this, I'm going to multiply the 10 in front. It's going to cancel the 1/10. And then it's going to be x, drop that by 1, x to the 9th, plus 0. Oh yeah, x to the 9th. That's what I had as the derivative. This is the antiderivative, or the integral. The third one, I'm looking for something whose derivative is 1 over x. And remember, that was ln. Now, since I don't know whether x is positive or negative, I do the ln of the absolute value of x plus c. So where you might see this is maybe you have an x to the -1 dx. And you say, oh, I know that's the integral of 1 over x dx. So that's just ln of absolute value of x plus c. But realize it's only for x to the -1. We'll talk about that soon when I do some more examples. And then down here, we're doing the antiderivative of e to the e raised to the ax power. Well, remember, if I were taking the derivative of this, I get back the entire exponential e to the ax. But then I say, oh, chain rule says times the derivative of the exponent, which is going to be times a. Well, I'm going backwards. So instead of multiplying by a, I multiply by the reciprocal, 1 over a. Or just divided by a, whichever way you want to put it. So in this case, as an example, say I've got e to the 3x dx. Well, I'm still going to keep the e to the 3x. Notice I don't go up or down any in the exponent. That's not how exponentials work. It's not a power rule. We go up or down 1 depending on if it's an integral, we go up 1, derivative, we go down 1, if we have a constant as the exponent. But if we have a variable there, it's an exponential function, doesn't work the same way. We get back the exponential. And remember, if this was derivatives, we'd say times 3. So instead we say, oh, 1/3 plus c. So if I took the derivative of this, I get e to the 3x times 3. Well, that times 3 is going to cancel with the 1/3. So I still get the e to the 3x. And then the plus c again is going to go to 0. So there's our 4 basic rules for integration. Now there's a couple properties. Let me show you these in a couple of examples there so you see them. So let's erase this. And we'll just say properties. I'll list 2 of them and I'll do an example of each one. So properties, and I'll just list just properties. We know what we're talking about. The first one just says, hey, if I've got the integral of a constant times a function, I can factor that constant out and just do the integral of a function. Just like we did with derivatives, I can factor out the constant multiple and then take the derivative. Also, another rule says, hey, if I've got the integral of one function plus or minus another function, I can just break those up like with derivatives and do them separately. So I can do the integral of f of x dx, and then plus or minus the integral of g of x dx, whichever is appropriate. So those are two properties I'm using. Let's look at examples. So here's one example I like, which brings in a lot of the rules and a lot of the properties. If I do something like, for example, the integral of 3x squared plus 4x minus 7 with respect to x, I can look at each of these individually using that last property I did. I'm thinking this, oh, that's the integral of 3x squared dx plus the integral of 4x dx minus the integral of 7 dx. And we usually don't write that down, we just think it in our head. And with these, I can actually factor the constants out. So it's 3 times x squared dx plus 4 times the integral of x dx, and then minus the integral of 7 dx. And I can do each one of these. Now, remember what we used to do? We used to say that plus c. We don't have to say a plus c after each of these because we have 3 constants, and whether we're adding or subtracting constants together, it's still going to be a constant. So we can just put 1 plus c at the end, no matter how many pieces we have. But now I can use the power rule. So the 3 is a constant multiple, it's going to stay, but this goes up 1 in the exponent, so it's x cubed, but then multiply by the reciprocal. This one's x to the first go up 1, so it's going to be x squared. We still have this 4 out here, but multiply by the reciprocal. And then the minus 7 is just minus 7x, and then we just attach this plus c at the end. And so we see, oh, the 3 cancels with that 1/3 there. We get x cubed. The 2 goes into 4 twice. We get plus 2x squared minus 7x plus c. There's my answer. And again, how do I check? By taking the derivative. The derivative of this is 3x squared plus 4x minus 7. And then the constant's going to go to 0 when I take the derivative. So we use a lot of properties and a lot of rules on this problem. I like that one real well. Here's another one I want to show you. Suppose we have something like, find the integral of 5 over x plus x to the negative 3 with respect to x. So say we've got that. Now it's a negative 3, it doesn't look much like a 3. We'll help it out a little bit. Well, realize this first one, so I'm going to break it up into 2 integrals, but I'll do it together. I can factor this 5 out, and then it's just the integral of 1 over x. And we'll look at that separately. We'll go dx. Plus, now notice, if I wanted to, I could say this is 1 over x cubed. But that's not just 1 over x, so we're not going to be able to do the ln. This one we can do the ln. This one we cannot. So I'm actually going to leave it as x to the negative 3, so we can use the power rule. So this one we can say it's 5 times the ln of the absolute value of x. This one we're going to add 1 to the exponent, negative 3 plus 1 is a negative 2. Multiply by the reciprocal, and then plug in your plus c at the end. And we'd probably want to clean this up a little bit. We'd probably go, oh, it's 5 ln of the absolute value of x minus maybe 1 over 2x squared. Or you could do negative 1/2 x to the negative 2. We usually don't like to leave negative exponents, but we could. Either way would be fine. That's my answer. And again, check it by taking the derivative. Well, the derivative of this, 5 times the ln of absolute value of x, that's going to be 1 over x. Oh, 5 over x. Yeah, so we got it. And this, especially if we think about it here, -2 times -1/2 is going to just be 1, x to the -3. That's what I got. And again, the plus c goes away. You may say, why can't I use the power rule with this? Well, notice if I do 1 over x dx, that's x to the -1 dx. But if I add 1 to the exponent, it's going to be a 0. And then I multiply by the reciprocal, I get 1 over 0, x to the 0 plus c. I can't have x to the 0. That only happens with 1 over x, or x to the -1. That's why that's the only one that's the ln of x. Any other x to a power on the bottom or x to a negative exponent, you're not going to get an ln. Just use the power rule. All right, practice this. Hopefully that helped you out, get you started. And you're going to do a lot of these, so do practice. You'll get better and quicker as you do them. But remember, there's just those 4 simple rules, and then plus the 2 properties. So again, if you like this video, click like. Please subscribe to my videos if you haven't already. Subscribe to my channel. But other than that, keep at it and keep going, because you're going to get this.